just in case you weren't sure if we were at Alderdice. There we go. All right. So, last theorem. Last theorem. So far, we have 4 rules, 4 laws for proving triangles congruent. All 3 sides, 2 sides in the included angle, 2 angles in a side, either the included side or the non-included side. That's what we got so far. Notice they all have 3. You need 3 things, either 3 sides or some combination of sides and angles, but you always have to be able to write 3 congruency statements. Okay. This last one that I'm going to show you is special. It's special because it's only works for special triangles. Okay. So this last theorem, number 5, I only count it as a half theorem, I'm not going to lie to you, because the fact is it only works on right triangles. And most triangles aren't right triangles. But in the event that you're looking at a pair of triangles and you see right triangles, like these ones that are here with these little like squares in the corner there, we know they're right triangles, hopefully you'll say, I think I can use this. Because otherwise you might look at it and say, I don't have enough information. But what you have to remember about right triangles is there's some information hiding in there. So you may recall from, who knows, you've probably seen this formula 10,000 times, right? A squared plus b squared equals c squared. We know that this formula, the Pythagorean theorem, only works for right triangles. And what this does is it tells us the relationship between the 3 sides. A and B are called the legs of the triangle, and C is the hypotenuse. Right? And we know in a right triangle, again, the legs are the 2 sides that create the right angle. So this is a leg and this is a leg. And the hypotenuse is always the side across from the right angle, and it's always the longest side, for sure. Okay, so here's the thing. Because we know right triangles, in any right triangle, if you know 2 sides, you know the third. Right? And you might not know it right off the bat, but you can always figure it out. So for example, in these 2 pairs of triangles, if we knew these 2 pairs of triangles were congruent, look, we've got 5 and we've got 4. We have 2 of the sides. Right? We can use a squared plus b squared equals c squared to find the third side. So because of that, I don't actually need 3 congruencies because I can cheat it a little bit with right triangles. Again, here's why. These 2 triangles here, I have an angle congruency, right? I have that angle A and angle, not angle A, angle C and angle F are the same. That's an angle congruency. I have these 2 side congruencies that AC and FD match, right? That's a side. And I have that AB and ED match. ED. That's a side. The problem is, this is one of those ones where we say side angle side is real finicky like. Right? Remember, if you have 2 sides and an angle, it's got to be the included angle. And look what the problem here is. I've got these sides. Cool. I got these sides. Very nice. But if those are the 2 sides I'm going to have, I need to have this angle right here. The one that's included. The one that's where the 2 come together. And that's not the one I have. Okay? So without this new theorem that I'm going to show you, we would have to walk away from these 2 triangles. We would have to say, you know what, I don't know. I don't know if they're congruent or not. The fact is this. I could take that 4 and that 5, and I could use them to figure out what the third side is. In fact, the Pythagorean theorem would tell us that third side is 3, right? If I went and did it. And if I know the third side, then I can make this angle work for me, right? Because if I know the third side, then I can use this side and this side. Suddenly I have an included angle, and bingo, bango, my triangles are congruent. So this theorem I'm about to show you is a cheat. It only works for right triangles. Okay? So if you're looking at two triangles and you have two sides and an angle and it's not the right angle and you're like, oh, this is a last resort. Last resort. Right? If they're right triangles, we'll be able to use this one. Okay, here it is. I call it not really a new theorem because it's not. It's two sides and an angle, right? Okay, we call it HL, and HL stands for hypotenuse leg. Whoops. Oh, there we go. Sorry about my floating head being in the way. All right, HL stands for hypotenuse leg. H being the hypotenuse of the triangle, or the long side, L being one of the legs. So over here in these pictures, my hypotenuse, which is what the H stands for, is the side that is across from the right angle. It's got to be that side. The leg, on the other hand, could be either of the other two. It doesn't have to be a specific one. It could be either of these. These are both legs. In this case, this is the one that's marked. Okay? So if you've got a right triangle, and on that right triangle, all you have to have is two markings, hypotenuse and a leg, and you're good to go by the hypotenuse leg theorem. Okay? Again, in any other triangle, this would be a problem, because in any other triangle, this would be two sides and the wrong angle. But this isn't any other triangle. This is a right triangle, so we get to cheat. Okay, because in a right triangle, I can easily know the third side. I could go do some work and look at the Pythagorean theorem and prove that, yeah, the other sides are the same too. If these two are the same, the third sides have to be the same too. Pythagorean theorem tells us that. We'd rather not have to do all that work, right? So if you're looking at a triangle and you see two sides and an angle and it's the wrong angle, ask yourself, is that a right angle? Because if it's a right angle, you're good to go by hypotenuse legs. This is our fifth theorem. It's only a half a theorem because it only works on right triangles. It's a little bit of a cheat. Okay, so here's the theorem. It says if the hypotenuse and a leg of one right triangle is congruent to the hypotenuse and a leg of another right triangle, then they're congruent. So here we go. Again, the sides that are across from the right angle, those are the hypotenuse. The sides that are not across from the right angle, the other two, the two that make up the right angle, those are the legs. And again, it could be either of them. So in this case, the only congruencies that I need to write down are the two side congruencies. So I could say that since BC matches EF, and that's my hypotenuse, and then for my leg, AB matches DE. That's all I need. I don't need a third congruency. So I have right triangles. I have a pair that is legs, and my other pair, my other set of congruencies is the hypotenuse. Right? So I can say these two are congruent. So I'm going to say triangle ABC is congruent to triangle DEF. Whoops. Okay, so I want to show you two images down here, two pairs. One of these is hypotenuse leg, the other one isn't. Okay, and let's check out why. In this one right here, well, in fact, in both of them I have a shared side, right? Shared side. Shared sides are awesome, right? In both of these, that shared side happens to be a leg of the triangle. So notice the sides that make up the right angle, those are the legs, right? So this green side right here helps to make up this right angle. So it's a leg. Over here, this green side helps to make up the right angle. It's not across from the right angle, it makes it up. So that's a leg. So those green sides that I labeled, those shared sides, those are legs. Oh my. Okay, now let's look at the other side we were given. On this side, on this diagram, we're given that this side here is congruent to this side on the other side. So look what I'm given. This side right here that they gave me just happens to be across from the hypotenuse, or the right angle. So that side here that they gave me, this is the hypotenuse. because this side is the one that's across from the right angle. That's my hypotenuse. Since I have a hypotenuse and a leg, I can say HL, these are congruent. That's the theorem I want to use. That's not the case on this right side. Okay. Look at the other side they gave me. I used green, right? Let's use purple. Okay. This side right here, this is one of the ones from my pairs. Guess what? It's another side congruency, but that's not the hypotenuse. Right? The hypotenuse is this one right here, AB. Right? It's the one across from right angle. So they gave me, what they gave me is another leg. I don't have a theorem called leg-leg. I have a theorem called hypotenuse leg, HL. Now, does that mean these aren't congruent? No way. You already knew how to call these congruent before we even started this video. Look what you have here. You have two sides and you have the angle that is between. It's not that these aren't congruent. It's just that they were already congruent before we knew who hypotenuse leg was. This is a side, angle, side situation. You have two sides and you have the angle where they come together. Okay. So my point here in showing you that is this. Always try for things like side, 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 angle, side, stuff like that first. If side, angle, side isn't working for you, and if you're going, I don't know, I don't think I have enough information here, double check and see if they're right triangles. Because if you have right angles, HL could be just what you're looking for. Right? But more often than not, it's going to be one of the other four. The other four are the big ones, right? This is one very, very special case. So I don't want you to use it as like your first thought. Right? Mark your congruencies. If you happen to have two sides at an angle, and it's not working out with side, angle, side, ask yourself, do I have right triangles? Because if you do, it's possible that you have a hypotenuse leg situation and you could still prove congruency. Because otherwise you're going to have to say, not enough information, sorry. Sorry, Charlie. Okay, so here is our final theorem. We can finally finish this. I've been staring at this chart for a long time. So here they are, the big four, right? Side, 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 angle, side, but it's picky. It's got to be that included side. Up here, the ones where you have two angles, so angle, angle, side, or angle, side, angle. I don't care which side you have. It's just a matter of which theorem you're going to pick. And now finally, the last one, the special case, the hypotenuse and leg of a right triangle. So we call it HL. But it's only right triangles. If you don't have a right triangle, you cannot use this. So if you're writing this, you want to note this is a special case. Only for right triangles. Don't try to use it if the triangles don't have right angles in them. Okay. If you don't have the hypotenuse, don't use this. The H in HL stands for hypotenuse, right? So if you don't have the hypotenuse, if what you have is both legs, then what you have is side, angle, side, right? If you don't have side, angle, side, this is where you look, right? This is a last resort. And notice I said here again, only as a shortcut for right triangles. You don't ever, ever, ever want to try to use this on something that isn't, on something that isn't a right triangle. Okay, so again, the first thing you're always looking for are side congruencies. If you find two side congruencies and an angle, and side, angle, side isn't working for you, see if you can make it fit hypotenuse leg. It's the last one. It's all you have left. Okay, so that's our last theorem. We're going to do a little bit of practice on all 5 theorems put together. You know there's a Quizlet coming. Okay, we'll see you soon.